Test, 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 test.
Hey.
Hey, hey.
Did you get a haircut?
No, I was just looking at it.
Your hair.
I don't know why it looks so slick. But that's funny that's funny. That's the first thing you said, because that's the first thing I noticed when I got on. I was like, why is my
like cutting off your hair? Yeah.
I don't know. Maybe it's the virtual background makes it not look as poofy.
I don't know. That's funny.
Hey Brian, I'm Nick.
How's it going?
Nice to meet you, man.
Likewise.
Thanks for doing this.
Hey.
Hey there.
Hey Steven, I'm Nick. Nice to meet you.
Nick, nice to meet you. This green screen thing does not work very well.
Yeah. Lindsay was just saying my hair looks
behind me.
Yeah. Yeah, Brian, yours is exceptional.
It's just a white sheet that I strung up wall to wall.
That's funny.
That's why I'm not cheating.
Hey Mike. Hey Chris, I'm Nick.
Hey.
That's Lindsay.
Hey.
Somewhere.
All right, so this is everyone, right?
I think so.
Awesome. So Nick, everybody has a presentation, so they're all gonna at some point share their screen. So do we want to run through and make sure everybody is good with sharing their screen, and then?
Yeah, definitely. I need to make a change of setting here. Okay, everyone should have sharing access as of right now. I don't know, Brian, you want to go first? Can you pop in and make sure you can?
Yeah, I just had to make sure I download the latest version. So of course we're going until oh, there's Chris sharing.
Oh, we should have put ads in this. Make some extra cash.
Oh, I just realized I was on mute. Okay.
Chris, you're really quiet. Slides, right? Yeah. I assume it's all working fine.
Looks good.
Cool. Sure, I have this preloaded on my slide.
All right, I can go next.
Here you go. Okay.
Slides. You can see like when I highlight stuff, right?
Mm-hmm. Sure can.
Cool, cool.
We need to make sure Mike can see his drop down in the file dialogues.
Yeah. All right, so let's go. That. All right. So, oh, that's interesting.
Oh, you have another window.
You see the green square?
Yeah.
Yeah. All right, so let me try having a full screen from the get-go and see if that makes a difference.
Anyway, you can still see all your slide, but
how about that?
That's a little better.
Do you still see the green square though?
It is on the outside, yeah.
That's odd. All right, so yeah, I can do all this. And can you see the mouse and when I highlight?
Yep.
Okay.
All right, and then if I do that, do you see the menus?
Yep.
Yeah.
Perfect.
All right.
Yeah, all good. Everybody good?
Mm-hmm.
Hey guys, can you walk me through the order? Are you doing all four at the same time talking, or is it one at a time? What's the sequence?
It's going to be first Chris, then Mike. I hope I'm pointing in the right direction on everyone's screen. Then me, and then Brian.
Yeah.
And then I think back to Chris, maybe.
Yeah,
Chris,
if you look at our
Steven, and then Brian.
Yeah.
Chris, Mike, Steven, Brian.
Yeah, this
Yeah.
is footer right here. And then it might go back to Chris if he wants to take up the.
Gotcha. The end.
Yeah. Chris, do you want to do that?
At least speak. I think we can leave it on your. You can share the slide, and I'll, I guess, close up
Okay.
speaking.
You guys, when we go live, I can introduce you all and I'll say the names. Do you guys want to talk a little bit about yourselves first and introduce yourselves that way, or do you want to go straight into the presentation?
We were planning on going into the presentation and kind of giving a little brief introduction in each phase.
Okay, awesome.
So Mary, you just need to introduce the session itself.
Yep.
Does that work, Chris?
Sounds great.
Cool. Do you all have, if you go non-video, do you have headshots or images, or what do you all have as your icons? I'm just curious.
I think mine's just my name.
Yeah, it looks like same here. How do you
Name?
change that?
Okay. Yeah, the reason I ask is because it's a little distracting to have so many faces at the top. I'm wondering when you're not speaking, can you guys go undo the video so that focuses on the one who is speaking? Cool.
Yeah.
Thanks. Yeah, there you go. So right now you just have Steven. Perfect. Yeah. And then what you'll see from us, so you'll see a logo for me. I think Lindsay, you have the webinar logo. And Mary, do you have the PyRVA logo?
Mm-hmm.
Cool. So it'll look branded, and it'll look sharp on recording too. That way.
Nice.
How do you even update your image on that?
You have to go into your Zoom itself, your Zoom account, and then should be the icon. I think they just put a generic placeholder there until you put a nice, photo overlooking the world like Mike's. Oh yeah, there's Mary. So we got the PyRVA logo there too. Is that copacetic for you, Chris, if we do that? Any issues? Cool.
Sounds great.
I don't even know if I have a Zoom account or not.
Oh, I guess that's possible, yeah, because you can just open the
No, I'm
link.
not gonna mess this up right now.
You got 8 minutes.
Yeah. Last chance to register. All right.
Cool, and we'll broadcast. We'll start right at 12, and then Mary will let it run for about 30 seconds to a minute, just to let everybody kind of get in, and then she'll kick it off.
Sounds great.
And Chris, we've gone all the way up to 1 o'clock. Sometimes we've ended at 12:35 if the content's over and there are no Q&A. So it's totally up to you and how the flow is rolling.
Awesome.
And Chris, can you see the Q&A in the chat boxes down below?
Yes.
That's where Mary will direct people to put in comments if you want to check that yourself, and structure the conversation.
That sounds good. Yeah, I guess at the end of the talk, I will open that up and even probably ask the questions that Steve and Brian and Mike, you guys can weigh in if you like.
Cool.
And Mary, I know this is kind of new for us, but I'm not going to bring in people anymore. It looks crisper on the recording if we don't bring in the attendees as panelists. It was good at the beginning of COVID when we just needed to see other humans. But
that's true.
But now we're in, production value is the priority.
So how many people do you expect on here?
A million or two. It's worldwide, man. Hang on, let me check. Probably not that. Our attendance numbers have admittedly dropped off just due to, I think, Zoom fatigue, but let me check. And for what it's worth, we'll record this and we'll actually cut it up and put it out on social media, throughout the coming year too. So, and it'll also live on our website. So if you need to link back to it for other conference, submittals or anything like that, you can.
Resume stuff.
Yep, exactly. Let's see, where are my webinars? Yeah, 27. It's not bad. That's about where we are, to be honest, on most of the things.
That's about
Yeah.
one of our average meetings, so that works
Oh.
well.
These are in-person meetings.
Perfect.
Back when in-person was the thing.
Yeah,
And before
I barely remember it at this point.
Yeah.
Oh, man. I should also make sure that the app is still working.
Hey, Nick, since we're not, I haven't done this since we're not putting people to panelists, do I still wait like 30 seconds before starting? Okay.
Yeah. Just because not everybody logs in, you know, a few
Like,
minutes
right,
before.
okay.
Yeah, yeah. You'll see the attendee number jump, start to roll in.
Is anyone gonna direct them to our repo for the slides? It would either be Chris or Mike.
Yeah, I guess I'll go ahead.
Yeah, if you want to do that.
Yeah, I'll do that. Yeah, I'll do that.
At the end or something.
Yeah.
Yeah, that's probably the right place to do it because that's where we have the link for it too.
It's not exactly something we can email out easily.
Right.
Hey, Chris, the three of us will be online the whole time, so you'll see us up here. We'll jump in if there's any technical difficulties. And the first thing I'll do in the chat box is actually put in your LinkedIn hyperlinks, if that's okay, so people can connect with you.
Sounds wonderful. Thank you.
Cool. Yep.
And Chris, you're presenting first, right? So I'll hand it to you after I introduce you guys.
Yeah, sounds great.
All right, Mary and company, we are at 12, so I'm gonna go ahead and hit the broadcast button if that works for y'all.
Sounds good.
Cool. All right. Here we go. We got 3, 2, 1, broadcast.
Hello, everyone. Thanks for joining. We'll get started in just a couple of seconds. We're letting everyone roll in. Again, thank you all for joining. We're going to get started in just a couple of seconds. Awesome. Well, we'll go ahead and get started. Thank you everyone for joining us today. Today we have an awesome panel coming from PyRVA, and they're going to be speaking on Python 201, taking it to the next level. And our speakers today are Chris May, Brian Cohan, Mike Alfair, and Stephen Lowry. And with that, I will hand it over to Chris, and thank you guys for being here today.
Well, thank you so much for having us. We're very excited to be here, and thank you for this opportunity. Let me share my slides real quick. Yes, hello, my name is Chris May. I am a full stack engineer at Markel. I'm a part of Markel's innovation team, where as a team, we seek to remove barriers for our colleagues and enable them to do more. And I'm lucky enough that I get to use Python to make many of that possible, whether it's building a website or building a tool or automating a report or something like that. I feel very lucky to be there. In addition, I'm one of the founders of PyRVA. And let's speak just a little bit about PyRVA. If you're not familiar with us, we are Richmond's largest Python group. We have, nearly 1,500 members who are following us on Meetup. And in just a couple of weeks, we'll be 5 years old. And we have a very active community. Every month we have, on the second Wednesday of every month, we have a lecture night. And then the fourth Thursday every month, we have a coding night. So we're very excited we still meet online. And so we don't meet in person right now. We're excited to do that when we can. And we encourage you to come out. If you are a little intimidated by the thought of being around a bunch of people who know Python, I want to encourage you to come out anyway. We're very beginner friendly. We've all been there. We know what it's like to try to learn Python, to try to learn any language. And yeah, we exist to just try to help people learn Python and to enjoy it. So when RVA Tech reached out to me and to PyRVA, I reached out to the whole group and said, hey, would anybody be interested in talking about Python and spreading the word? We had quite a few volunteers step up. And as Mary mentioned, we'll hear from a few of them today, Mike Alfair, Stephen Lowry, and Brian Cohan. And we want to talk about this because we just really enjoy Python because it is a very unique language. Guido van Rossum is the man who created Python. When he decided to make this language, he took to heart the adage that code is read far more than is written. And so he made it a priority to make sure that the syntax of Python was simple, readable, and understandable. The syntax is actually so simple that elementary schools are actually using Python to teach kids how to code. It's really quite interesting to me and amazing too that that's going on, because not only do you have elementary school students learning Python, but on the opposite end of the spectrum, you have these big corporations, big organizations like NASA, Wall Street, Instagram using Python to do powerful things. And they're using what I would consider Python's powerful ecosystem. Because right now there's something called the Python Package Index. There are nearly 260,000 packages that you can download and use to do whatever you'd like, whether it be hosting a website, analyzing data, generating PDFs, whatever you want. There are solutions available for you out there that you can just incorporate into your code. And I think it's this combination of simple syntax with very powerful things that are already built for you that you can just use and download that have contributed to Python's popularity. Because there's a core contributor named Glyph who's once said, Python is not the best language at doing any one thing. But the moment you want to do more than one thing, Python quickly rises to the top. And he says that because Python is, like when you're running Python code, it's not as fast as, say, C. And yet there was a small team of Python developers that went head to head against a team of C developers to be the platform that would host videos. And time after time, the C developers could not bring features to market as fast as the Python developers could. So in the end, Google bought the group of Python developers, and now we know YouTube is the place you go for video and not Google Video. So it's pretty impressive what you can do with Python. And we want to share just a little bit of that by showing you how to accomplish several different tasks today, all within Python. First, we're going to talk about a package called Podium, with which you can create slides such as the ones we're using today. And then we're going to show you a different kind of use case of like how you can pull data from Twitter. And then once you pull that data, how you can analyze it using a simple bar chart. And then how to like take it to another level completely by using a package called Streamlit, which will give you a interactive website where you can change the data, interact with the data from Twitter, graph it in different ways, and try to understand what's going on. It's pretty exciting, and I hope you'll enjoy it. But first off, we're going to switch over to Mike Alfair, where he's going to talk about Podium.
For some reason, oh, there we go. For some reason, my video isn't starting, but now it seems to be working. Thanks, Chris. Let me share my screen first. All right. So my name is Mike Alfair. I work at Kaleo now as a data engineer and architect, and we use Python on a daily basis to get data from a bunch of data vendors into our warehouse and use it for downstream reporting and analysis, and it just makes it super easy. Our code reviews are usually about like business rules and why we did certain things, and not like, oh, what does that code do, right? Because it's just really easy to use. So yeah, I'm super happy that that's what I get to do on a daily basis. And before we get into the exciting data processing and analysis, I want to first take a look at just the slide deck itself, because we actually used Python to do that as well. And so we used a tool called Podium that uses a variation on Markdown to produce slides, and that's from a project called the Beware project. And for those of you who are not familiar with Beware, their mission is basically to get Python to run everywhere. So not just across different operating systems, but also on different devices, like your tablet, your phone, things like that. And so to do that, they are focusing on being able to package up Python in a device agnostic way, being able to use native capabilities on those devices in a device agnostic way, and then helping developers with tools to debug, analyze, and deploy these projects. So there's a lot that goes with that. So Podium is just one tool in that whole toolkit. So let's talk about how to make a slide in Podium, right? So right now we're looking at the code that's behind that slide we just looked at. And so you'll notice some common Markdown things like the how to get an image in there, how to link to something, or how to create bullet points. So these are common Markdown things. But then you also see things like the .left column, .right column, which is what gave me the two columns. This class title, which is a formatting thing for how the slide gets formatted. And then these three dashes here, which indicates that that's a slide. And then the three at the bottom would indicate that's the next slide. And so this code produced that slide right there with the two columns. All right, so great, you have your Markdown for your slide. How do we actually see the slide and not just text, right? So it's a pretty simple process. You go to the GitHub releases page on the Podium repo, download the binary for your operating system. In this case, I'm running this on Linux. So the next step is actually to make that executable, to make that file an executable file. And that's a one-liner. And then you have to get your Markdown file and put it inside of a directory with a .podium extension, sort of like how a zip file would work. And then Podium can see that whole thing. So this, along with any other files in there, as one complete slide deck. And so you can put other things in this directory, such as images and things like that, formatting CSS and whatnot. And so then you just open Podium, select that directory, and you get what you're looking at right now. So you can probably see on my screen that we have this file bar up here as well. So you get a few options with it, right? So you can open a deck, you can reload the current deck, you can full screen the deck. And there's a few other options that are traditionally used more with these keys. So you just move left, right to navigate through the slide deck. And this, in particular, this I use this a lot because that actually acts sort of like when you're doing web dev and you have to restart the server because you made some code change, you want to see the update. And so you just kind of make those changes in the Markdown, hit this reload slide deck, and you see your new changes. And so that became pretty natural over time. And then there's another screen that you can't see because it's my screen, it's the presenter screen. And on that, you'll get both the current slide and the next slide, so you can see what's coming up. You'll have presenter notes, which you can put right in the Markdown, and it will show up in the second screen, but not in the slide. And then it will show a timer, so you have an idea of kind of what your pace is and where you are. And then, so that's a lot of functionality, right, in a tool. It's maybe more basic than PowerPoint, but it has all the things you need to do to have a presentation. So how did Bword do this, right? It's a pretty simple package. So Podium is pretty straightforward. And this is Podium, this is Bword's code, right? Like we just use the application by itself. So we're just looking at Podium's code for the sake of seeing how straightforward it is to use Python. And so there's, if you want to add a command, so if we want to add that reload command here, or if for Bword to add that reload command here, all they had to do was add the function that they wanted to call, give it a name, give it a keyboard shortcut, and say where to put it in the menu, right? And then if we look at the UI piece, then to create the actual UI on startup, there's just this method here, which is pretty short, where you say, you know, I need a web view, and then I need to add a style to it, so it knows kind of what it looks like. So it's things like the aspect ratio. You have to hand it a controller for the key press. So, you know, when you hit left, right, or control R and things like that. And then the actual content itself, like what are you presenting? And that's all you need to get this, this going. So that's kind of what the code looks like behind Podium. And you'll be surprised to know that it's only about 500 lines of code to get Podium working. So that application that I downloaded to do this is pretty small. And it's because it leans on other packages that Bword has built, and that kind of helps how I work with this modular ecosystem where you say, okay, I need this thing to do this and this thing to do this. So then my code will be much more straightforward. And so the two packages in particular that Bword uses to build Podium is Briefcase, which is something that turns that Python package into an executable on your desktop. So you don't have to stand up a virtual environment and run that code yourself or whatever. You just open Podium and say, I want to present these slides. So Briefcase lets Bword do that. And then Toga, which you may have noticed, a lot of the objects in the previous slides were from the Toga package. What that does is it abstracts away the native UI components on that system. And so it will just see that, oh, I'm on Linux, so I'm going to use these plugins or whatever. And then if someone else is on Mac, it's going to use theirs. And the code itself doesn't really care what OS it's running on. So with that, I'm going to hand it over to Stephen so that he can talk about getting Twitter data with Matplotlib.
Thanks, Mike. Hi, everybody. My name is Stephen Lowry. I am a data engineer in the data practice with EPON Technologies, and I use Python to do pretty much everything in my role, from building CLI applications to orchestrating data pipelines. Today, we're going to be talking about building a simple bar chart using Matplotlib, a Python visualization library. And we're going to put counts of tweets with a particular hashtag on a bar chart. So let's go ahead and get started. All right, so the first thing we're going to do is get some Twitter data by hand. So we'll go ahead and pretend we searched on Twitter for everything with the PyCon hashtag. We can go ahead and copy tweets we find along with the day they were tweeted and save them into a file that looks something like this, where we put the date followed by a comma, followed by the actual content of the tweet. This type of file is known as a CSV file, or comma separated values file. And Python actually comes with a library for working with them called CSV. So once we have our data, we can go ahead and read it into Python using that CSV library. So the first thing we're going to do is import our CSV library. We're also going to import a tool called pathlib that ships with Python. It's going to make it a little easier for us to access our file. So we'll make a function called getData that'll get our data for us. We'll start at the base path, which is the current file. We're going to assume we saved our file in a file named tweets.csv next to it. So we'll go up one file from our current Python file with .parent. Then we'll go down one with the dividing operator into tweets.csv. So now we have something pointing to the path of our Twitter data. We're going to open that file using the .open method and give it a name, f in this case. And we're going to use the dictReader class in the CSV module to read the content of f. And we're going to create a dictionary from the columns within our file. So we're going to pass in the names date and tweet. And if we look back, we'll notice that this corresponds with the first column and the second column of our CSV data. Then we will read each line in the file with our reader here. And we will have a single dictionary for each tweet we saved in our file in a long Python list. So now that we have some data loaded into Python, we can go ahead and analyze it. So what we're going to do is we're going to figure out first what dates we're going to put on our chart, and then we're going to count how many tweets are on each day. So we'll start out by getting a unique set of all of the dates in our data. We're going to do that by using the set collection within Python. This collection is special. It stores values by their hash, which means it will only store one unique copy of a data set. So we can use this to get all the unique dates just by passing in all the dates from our data set, and we'll save just one copy of each. But since we want our data to be sorted in chronological order to display it on a chart, and sets by themselves are unordered collections, we're going to transform that set into a list, which we can then sort chronologically by calling this .sort method. So now that we have all the dates that we're going to process tweets on, we can go ahead and start counting tweets and putting those counts in this values list. So for each label in our list of labels, we're going to count up 1 for each row in the data if that row's date matches the current label that we're looking at. So what this is going to do is it's going to go day by day and total up the number of tweets that occurred on that particular day. And when we're done, we're going to pass back all the labels for each date along with the list of values that corresponds with the number of tweets on that day. So now that we actually have some values and some labels, let's go ahead and put them on a chart. So we're finally going to start using matplotlib here. And we're going to create a very simple bar chart. So the first thing we need to do is import the pyplot module of matplotlib. And one of the conventions when you're working with this library is to import it as PLT. That means you don't have to type out matplotlib.pyplot every time you want to change something on your chart. You can just say PLT. So we'll define our draw bar chart method that will accept labels and values that we got previously. And to actually create our bar chart, all we need to do is say plt.bar and pass it the labels, the values, and what color we want our labels or our bars to be. And in this case, we're just going to give it the text blue, and it will know how to read blue and actually translate that into an RGB color value. But we're not going to stop there because all good charts label their axes. We're going to put an axis label for date on our x-axis, a label for tweets on our y-axis. We'll go ahead and give it a descriptive title, tweets using hashtag PyCon. And then we'll call this plt.show method, which will show our chart. So this is the basic chart that we created using our data that we scraped by hand. Now, getting data by hand every time is kind of a pain. You have to go and you have to figure out what you're searching for and find where the data is listed. It's kind of a hassle, and it doesn't scale up very well. So the next thing we're going to do is figure out how to get our data automatically. We're going to do that using a Python library called tweepy. Now, that will actually connect to Twitter's API for you and let you get tweets automatically without visiting the website yourself. The first thing you need to do in order to start using tweepy is to set up a developer account on Twitter. And once you fill out their application, they'll get back to you within about a day with some credentials that you can use to start querying Twitter. So once you've done that, you can go ahead and authenticate with Twitter's API. You can't just request data from Twitter. Even if you have an account, you still have to prove that it's you who's asking for data. tweepy actually makes this really easy for us, though. So we can define a getAuth method that will get our authentication all set up for us. We will create an OAuth handler from tweepy, along with the API key and some other credentials that we got out of the developer portal. And then we'll just set up an access token for the session, also using credentials we got from the developer portal. When we're done with that, we can return our auth and we're ready to actually start querying some data from Twitter. All right, so let's get to some tweets. So the API trusts us and we can actually send it a request. So we're going to define a new method called getTweets that will accept a query and a start date. And what we're going to do is go to the Twitter API and get all the tweets that matched this query after a certain date. So to do that, our data is going to be expected to be in this JSON format, where Q is a key that points to a query value, which will be our hashtag when we invoke this. We're also going to optionally include a start date. And if we do, we're going to key that start date under since, which is what Twitter's API will expect to use as the filter date. Now, Twitter's API is paginated. What that means is when you ask for all of the tweets ever, Twitter doesn't give you all of the tweets ever. It gives you the first 100 or so. And it says page equal 1. To get to the next page, you have to make a new request asking for page 2. And that'll have up to the next 100 until you get to a page that doesn't have 100 results or the last page. And then you're out of pages. This can be kind of difficult to manage on your own because every single time you want to query a paginated API, you have to reinvent that logic. So tweepy instead gives you a cursor method, which does that for you. So you just pass in the method you want to search. We're also including this extended keyword, which will just give us the entire content of a tweet rather than the shorter snippet. And we'll unpack the payload we built above that will put all of our requests and the information in the API into this search. So once we've done this, this tweet cursor will contain all the pages from Twitter's API, but our process data is expecting one list of dictionaries. So what we'll do here is we'll flatten out those pages using the chain from iterable method that is actually located in the itertools collection of the Python standard library. And we'll pass those back into a list and return them to the next method. So now that we actually have a way to get tweets from Twitter, we're going to modify our get data method from previously and change it to get our tweets directly from Twitter rather than a CSV file. So to do that, we'll start out by just grabbing all of our tweets with the method we just defined and give it a query of hashtag PyCon. The start date will be 2020, 8/11. We're going to then iterate over all these tweets and set up dictionaries just like we had before when we handed it to our process data function. The key date will point to when the tweet was created, and the key tweet will point to the full text of the tweet object, just like before. And we'll do that for each tweet and the tweets we got back from the API. Now, without changing anything in the process data, we're going to go ahead and run our chart again, and we get this chart generated for you automatically from the Twitter API. If we wanted to change the hashtag we were searching for, all we do is change this right here. We would get it for a different hashtag automatically. Now, if you wanted to share this with someone, you would have to take a screenshot or send them your code, let them set up an account on Twitter and do all this by hand. So Brian is actually going to talk to you about a platform for generating and sharing chart analytics called Streamlit.
Hello. Oh, yeah, start my video. Apologize for that. There we go. Now I can share my screen. Hello, I am Brian Cohen. I am a fire protection engineer with a company called GHD. So I don't have a strict programming role, but I do a lot of fire modeling, and each fire model can spit out a ton of data and want to be able to process the outputs quickly. So Streamlit is a tool that I've started using to do some of these analyses that I work on, and it's made a huge difference in my workflow, and it's really nice and easy to use. One thing I hope you all noticed in the code that Steven was showing was that you get a lot of functionality for very short function calls, and that's characteristic of Python. And Streamlit is no different. Streamlit is an open source app that can make really pretty good looking apps that you can deploy to the web, and you don't need to know any language other than Python, and you can even make interactive graphs. Again, just using Python only. One interesting thing about Streamlit is that a few months ago they announced that they got a $21 million Series A investment. So to me that means it's worth taking the time to really get to know it, because it's probably going to be around for quite a while. In a nutshell, what it does is it runs your app from top to bottom, just like a normal Python script. So it's easy to wrap your head around what's going on. It manages a whole bunch of stuff behind the scenes. If you're familiar with Jupyter notebooks, they can be a bit of a pain to work with because it's hard to track which order you execute the cells in, and this kind of eliminates all that. You can show your code in the middle of your app if you want, or you can keep it hidden depending on who your target audience is. You can work with any Python library you like. You can add interactive widgets. They have a really cool caching function, which we'll cover in a minute. And like I said, you can deploy it to Streamlit for Teams, which is a beta product at the moment. Or as we'll show you, we deployed our app to Heroku. So just to show you a quick, simple thing that could fit on the slide, say you wanted to, and we'll get back to the Twitter data in a minute, but we want to show like graphing live data from the web. So I chose to graph the attendance history for all of our meetings for PyRVA. And you can see I had to call in 4 different packages. Altair is great for graphing. Pandas does the data analysis. Requests will get the information from the web. And Streamlit will just make it look pretty. and interactive if you define elements. So we use the requests to get the URL. We're looking at past meetings, so we can get our past attendance history. And we read it into a data frame using pandas. And we just get the JSON that is returned from that response. If you want to see all the data, Streamlit has this write function. The write function will determine whether your variable is a data frame or a list or a dictionary or a string, and it will write. It will make it look good depending on what you pass into it. And then we can use Altair. This is effectively one line of code with the method chaining, but you tell it, I want the x-axis to have the local date as a time value. And then on the y-axis, we want to show the RSVP count for events. And then, as Steven said, make sure to use your titles. Otherwise, it will just use the fields as the axis titles. And then this is what it looks like. So in order to run the script, all I have to do is type Streamlit run and then pass it the file you want it to run. As you can see, we get this data frame here of all the data we pulled from Meetup, and then a nice looking graph that will show the attendance history. And since it's like data analysis, you can see that we picked up our meeting. So this is where we started our coding nights back in last July. So it's easy to pull analyses and insights from Streamlit, and you can add or subtract whatever else you want to view. They make sure to work well with a whole bunch of Python libraries, specifically aimed at data analysis and visualization. I think this was the impetus behind developing it. You can use any Python library that you can import, but they make sure to play well with these different libraries. And they even have some convenience functions for like Streamlit.chart, and it will automatically kind of figure out some of the columns that you want, or map if you have a latitude and longitude column in your data frame. All you have to do is call Streamlit map, and it will just show you a map. If you want more configuration, of course, you can go into the deck.gl and PyDeck. Interactive widgets. These are super simple, easy to make. I apologize if this is a little challenging to read, but you can see the code that we have to generate the widget. So for a checkbox, you just say, Streamlit, give me a checkbox, and you give it a label to go along with it. And then you can see the st.write. The value tells you true. So it knows, hey, I just passed a Boolean value. So I'm gonna give it this kind of look to it, as opposed to the radio is get some strings. So it presents it as text. Down here, you can see a multi-select widget where it gives you a list. So it formats that so you can see it as a list, as you would expect to be seeing when you're writing in Python. Some range value sliders. You can do either a single digit, or if you pass it for 2 default values, then it's a range slider instead, which is really convenient and super simple syntax to do this. And one other cool thing is that it even has a widget for uploading files. So if you have a CSV file that you want to just throw up there, all I have to do is drag and drop it, and it will work. The caching is kind of one of the bigger powerhouses in the way that they do it behind Stream. So it will check for the input parameters that you called the function with. So in this example, if I want to say foo of 2, or instead of foo of 1, it will recalculate it. But if I go back to foo of 1, it'll say, hey, I've seen this already. Here's your answer. That's pretty typical caching. But it will also check the value of any external values. So if you have something in your settings that might change, that's in a global variable that you call into your function, then that will get checked against. But also when you're developing it, if you change the structure of your function, it will know, hey, this is a new signature, so it will create a new entry in the cache. And even here where I call bar, if I were to change bar to say time sleep 2 instead of 1, it'll say, hey, I know that this function that I called is a new signature. So it makes it really easy to speed up your exploration, because you don't have to keep recalling all these expensive computations. And one issue that we kind of ran into in developing our app was we hit the Twitter API rate limit. So if you throw a cache on your function there, then it can say, oh, you already asked for the PyRVA tweets. Here's the answer I gave you already. And you can save yourself some of those calls to the API. Deploying is very simple. For Heroku, you only need 3 files. You need the app itself, which could be anything from just a single standalone script, or if you have a whole built-out package that has a whole bunch of different sub-modules to it, you can include that too. You need a proc file, which is telling Heroku what to do when it starts up your app. So we have it set up, run this setup script and say Streamlit, run my app. The setup script here will create a Streamlit directory and set some configuration options. Namely, tell it to run in a headless state so that it doesn't try to open up a browser on the machine itself, knows just to port the output to whoever's requesting the app, and setting port 80 instead of its default port. So what does this look like? I need to switch screens to so this is the app that we have. As you can see, I have it preloaded with RVA Tech and PyRVA, and you can see a timeline of when RVA Tech joined Twitter back in 2009 versus when PyRVA hopped on in 2015. You can see PyRVA has more followers, but RVA Tech is following more people. And you just have all these graphs. But say I want to add a few more, so I'll put in I can type my last name, and Chris in here, hit enter, and now you can see all the apps, or all the graphs have updated just from updating this one field. You can pull the description. I have this set so you can go straight to their profile, just so you can check things. Yeah, another thing to show you some interactivity is I have this set up. So if you have a function where, like say these favorites, it's kind of hard to really compare us because Chris is so far ahead of us. If you click on this checkbox, it kind of scales it out a little bit better in a log axis, so it might be easier to see. And these are set up so each chart could have its own axis set to log or linear. They also have multiple pages here. So they have this mentions page, and you can see that it kept all the Twitter handles from before. And we can see a timeline of when everyone tweeted. I'm not a very active Twitter user, so there's not anything here in the past couple weeks. But you can hover over and see exactly when the tweets were, and you can add in whatever data you want in these tooltips. This is some of that interactivity of graphing. And again, this is all using Altair, which is purely Python. It uses Vega Lite, which implements Vega, which is a JavaScript rendering. But you can also see, or you can also make these bigger, and you can see where RVA Tech or Chris May or PyRVA is tweeting from, whether it's on the web in green or Hootsuite for RVA Tech. Another